Grade 10s. So today we're going to be learning about acceleration. Now, acceleration is a very fun topic. As you can see that from I mean the lesson before when we talk about distance time graph and velocity time graph. That is really like acceleration. It's like okay, so we're talking about how fast something uh, an object speeding up as it moves in a certain direction. So in this case, we're gonna go in more detail about it. Um, so what you're gonna do is you're gonna go to this handout here. So it will be this link. Um, so that's what this video is about. We're talking about this link. Now, if you are still not sure about the that's you know what, I'm gonna make this as another practice. So try to do that as later on as a practice for distance time graph and speed time graph. But today we're going to be focusing on acceleration. So now before we get to acceleration, which the handout will look like this, you should download that in the Word doc so you can actually type it better. The format will be smoother that way. Now before we go that route, what I want to do is I will show you a video because it's actually really cool. And it really talks about what acceleration is about. Okay, so now I know this video is a little older, but because it's 2017, there's a newer one, but it's a lot longer, and I think the music is not as epic. So without further ado, let's watch this video. Okay. Wow. So the car actually went from 0 to 400 and then back down to 0 in 42 seconds. When I show this video to my 6-year-old to give him some context, it's like, the highway that we go on, we're supposed to go to 100. And daddy only goes up to a certain number, which is more reasonable in real life. And he's going way, way, way faster than that. Now, so there's a lot, just from this, there's a lot of acceleration speeding up. He went from 0 to 400 kilometers per hour. That's a lot of speeding up. And then you have a lot of deceleration going on at the same time. Deceleration means slowing down, go from 400 kilometers per hour back down to 0. Okay? So, again, this is just a gist in terms of what is acceleration and deceleration. So, I kind of pretty much talk about what the definition is again. But this video, or today's lesson, you're actually going to be doing a lot of calculation. And we're going to talk about a few ways to how to do calculations. Okay. So let me load up my document camera. Awesome. So in this case, we're going to be talking about, so we're going to have a few ways to talk about calculating acceleration. So the first one, you have this particular equation. So acceleration. Now, acceleration is a vector. Acceleration is a vector. It does have a sign over it. It does have a direction over it. So as you can see, I put like a small arrow over that. Okay, so that's acceleration. So you're talking about your change in velocity, how much you're speeding up or slowing down. So it is v final minus v initial divided by time. Okay, and just as you notice here in physics, the standard unit is meters per second in the velocity, and acceleration, the unit is meter per second squared, because you're talking about the velocity is meter per second, and you're kind of like, okay, meter per second. So it is changing of velocity. So the equation, the first equation of acceleration look like this. Okay, so I wrote it here. And then what I'm gonna do is put all the equation together. Okay, so the second equation looks more like this. Okay, and this equation is displacement equals velocity, initial velocity times time, plus 1/2 at squared. So basically what this will tell you is, okay, what was initial velocity? You're talking about something that is accelerating. So something is changing speed. Okay, so in this case, something is changing speed. You're talking about, okay, so to go from their initial velocity, when you look at, okay, how long have they been changing speed for? How long have they been speeding up for? Okay, that will give you the time. If you know how long they've been speeding up for, if you know what is their acceleration, like how fast were they speeding up, you can actually calculate the displacement. How much? What's a change in position? Okay, what's a change in position? So that's the second equation. Okay, so that's the second equation that involves acceleration. Now, we're also going to learn how to find acceleration using the VT graph. That's something that you've been doing for the last 2 lessons. Okay, and from the VT graph, that's we're talking about the slope of the VT graph. That's acceleration. You've done that in the last 2 lessons. And that's about it. So let's do some of these practice questions, okay? So, okay, so I'm gonna do some. Now these two, problem 1 and problem 2, you use the first equation. So I'm gonna just do the problem 1 first. So, a rabbit lives in Canada Wonderland, starting from resting position. And moves at 6 meters per second after 3 seconds. What's the acceleration of the rabbit? Okay, fair enough. So, in this case, you have the initial. So, question 1, the rabbit one. So, the initial velocity, the rabbit was not moving. Not moving means, or at rest means 0. 0 meters per second. Now, they said the rabbit goes from 0 to 6 meters per second. in 3 seconds. Okay, 3 seconds. Okay. So in this case, how fast is a rabbit? Or what's the acceleration? So you're looking for the acceleration. Okay. Now, so in this case, you're going to be using this equation. Okay. So you have acceleration equals vf minus vi divided by time, right? So you plug in all these numbers. Vf is 6 meters per second, and Vi is 0, time is 3 seconds. So in this case, you do that. 6 minus 0 is still 6. 6 divided by 3 is 2. So it is. So in this case, the acceleration is 2 meters per second square. And since this is a positive number, and as I said before, acceleration is a vector, so it will have a positive sign. So I'm just going to write positive out here. Okay. Do you have any questions? This should be fairly straightforward. Okay. Now, I'll ask you to do is pause the video and do the second question. Okay? Do the second question. Now, the second question number 3. I'm going to do question number 3 now. So problem number 3. Feathers drop from the moon from the height of 1.4 meters. There's no roller coaster on the moon, so I guess astronaut. Okay. The acceleration of gravity of the moon is 1.67. Okay. Determine the time for the feather to fall on. Why did I read hammer? For the feather to fall to the surface of the moon. So in this case, when the feather is dropped, okay, it's going down toward the center of the moon. So in this case, the acceleration, like how fast it goes from the astronaut holding it up here to when it drops onto the ground, that acceleration, that how fast it goes from not moving to going down at a certain speed, that acceleration is due to the gravity. On Earth, we also have that too. Like if you drop something, that acceleration, the value A will be 9.8 or 9.6. I don't remember exactly, due to the gravity of the Earth. Now, so in this case, let's calculate this. Let's do this question. Okay, so there's a lot of information given. Now, so when they're talking about dropping the feather from the moon at height of 1.4 meter, so I'm going to draw this diagram. So ground feather. I'm not an art teacher, so feather. Close enough, right? So 1.40 meter. It's going down, so I'm just gonna do what I always do. This is number 3, by the way, plus and minus. So it's going down by 1.4 meters. The feather, so it's going down. They're gonna hit the surface of the moon 1.4 meters. The acceleration. So the acceleration is given. The acceleration is 1.67 meters per second square. Now, since the acceleration, it's the feather going down, I'm also going to provide the negative sign here. So, determine the time for the feather to fall to the surface of the moon. So you're looking for t, okay? How long it takes for the feather to fall all the way. Now, keep in mind, you're using this other formula. Your D equals VIT plus 1 over V T squared. So what you need to do is, if you look at that, you have, now your D is actually given. It is the distance or the displacement, the change in position of the feather displacement is minus 1.4. So you have that. V equals minus 1.4. You have acceleration. You're looking for time. Now, the V1, the initial velocity of the feather. So when the feather is dropped, now, this is one part in physics you have to be very careful about. Okay, you have to be very careful. When the feather is dropped, okay, keep in mind when the feathers drop, just like my pen's dropped, I'm not. It's very different from throwing it. Okay, if I'm throwing the pencil or the pen, this will have a initial velocity. There will be a speed starting from here downwards. When I'm dropping something, okay, now you're watching it on video. So technically, what you could do is pull back to that frame on the video, and you. Now I don't know how many frame per second is this webcam, but if it is high enough, you would see a moment where my hand is completely let go, and the pen is just staying here in midair with not moving. You will see that frame if the webcam frame per second is high enough. If it doesn't, you can certainly try it on your phone camera. If you have a good phone camera, you at this point in technology, you would actually have a pretty good frame rate, which means you can actually see like that particular second when I open my hand and the pen has not moved. It's kind of hanging in the midair. So in this case, because the feather, or in this case, the feather is dropped, the initial speed is 0. Okay, so one thing, if something is dropped, initial speed is 0. If something is thrown, there is an initial velocity. Okay, so most of the time, you probably, when you're looking at a physics question, and something is getting dropped, something is kind of like going down, you usually see something is being dropped. You will hardly, unless you're studying more and more physics, or if we are just being evil, if we're being evil, then we will give you something that's thrown. But if it is something that's dropped, initial velocity is 0. Okay, so spent a long time talking about the same thing. So v1 in this case will be 0 meters per second. Now, so in this case, your formula d equals vi t plus 1/2 at squared. Awesome. So in this case, you're solving for t. Now, this is a super fun question. I can see this already. Yeah. So that's the equation. You're going to plug all the fun numbers in. So d is minus 1.4. V1 is 0. Now, because V1 or initial velocity is 0, you might as well just cross this out. 0 times whatever is just plain 0. Now you have 1/2. Your acceleration is minus 1.67. T squared looks like this. So in this case, you just so t squared will be now, to get rid of this 2, I have to multiply both sides by 2. So it will be 1 minus this times 2. And to get rid of this, I have to divide both sides by minus 1.67. Okay. Sorry with all the space. I somehow anticipate writing here, but I end up didn't. And to find this, to find just t, I'll have to square root the whole thing. Now you notice that I'm kind of trying to put everything all in one line. The reason why being is because if I can type my equation calculation on one step, it's more accurate that way. I know physics students and I know a lot of physics teacher. What you can do is you provide your final answer in a reduced improper fraction. That's another way to answer the question too. But if your math is so-so, use a calculator. So, by the way, I don't like negative signs, especially in the square root, but I do notice that, oh, a negative number divided by a negative number, so it cancels out. It's positive. Awesome, awesome. So, how will do this? Square root of bracket 1.4 times 2 divided by 1.67. That looks right. Yep. So in this case, be 1.2948. Okay, let's just say when looking at all these numbers, this is 3 sig fig, this is 3 sig fig, so I should round my final answer to also 3 sig fig, which in this case will just be 1.29 seconds. Okay, so that's how long it takes, as the question was asking, that's how long it takes for the feather to go from 1.40, okay, or maybe here, since I drew the diagram. So that means the feather takes 1.29 seconds from this position to hitting the ground, okay, on the surface of the moon. Do you have any questions? Okay. Now, last but not least, we're going to talk about how do you find these things in graph. Okay. Now, this is a big part. A lot of this section should be a recap from the last two lessons when we first learned about speed time graph, as well as last lesson when you were doing the gizmo. So essentially, the slope of the VT graph, that's your acceleration. Now, the one thing we haven't quite talked about is the area under the VT slope. Okay. So in this case, if you have something that has a VT slope like this, VT graph like this is the acceleration. Now, this area underneath here, that would actually be your displacement. What is a displacement or change in position from beginning to end? And in this case, it's very easy to tell. Something moving at a constant velocity or constant speed. Okay, so that's why the VT graph looks flat like this. So the acceleration is 0. Okay, the slope is 0. But the area underneath, 5 times 10 is 50. And lo and behold, the displacement itself is 50. Okay, so make sure you know this equation. And you're going to practice doing that a lot. Now, here for example, talking about VT graph. So the motion of the roller coaster during A. Okay. Now at this A section here, you can say that this is speed, this is time, or that's another way to call it VT graph. So in this case, it's going from 0 to 10 meters per second. So what's the acceleration? It should be speeding up. How much was it speeding up? So you look at the slope of this. So from 0 to 10 over 2 seconds. Now, I don't know how you learned that in math. I've always taught either rise over run. That's one way different teachers call it, or y2 minus y1 over x2 minus x1. Either way is the same thing. So if you look at it here, that's your y2. This is your y1. Okay, 2. So 10 minus 0 is 10. This is your x2, this is your x1, this is 2. So 10 divided by 2, this should be your acceleration here. It should be 10 divided by 2, which is 5 meter per second squared. Okay. Do that. Okay. Now, at this place here, the velocity, the speed time graph, as you can see, the speed has not changed. So because the speed has not changed and the line is flat horizontal, it is, what is acceleration? The acceleration is 0. Okay, it's it's moving at a constant speed. Now, next part, the speed goes from 10 to 4. So 10 meters per second to 4 meters per second. So in this case, it is slowing down. How much was it slowing down? Okay, was the deceleration? So again, your y2 minus y1. So 4 minus 10 will give you a minus 6. Okay, minus 6. Now you divide by x2 minus x1, so 6 minus 4, that should give you a 2. So in this case, you have a minus 3 meter per second square. Okay. Now, so in this case, what I'm going to ask you all to do is, for this section, same thing, it's the same concept. Look at this graph, the journey of the shuttle bus, figure out what is the acceleration, answer the following question based on different segment of the graph. Okay, you're going to be doing a design / something activity, which is very similar to that. Now, what I want you to do, the investigation. This one is, if you like cars, it's fun. Okay, use these websites. Okay, compare the acceleration of top 3 most expensive car in 2020 to the top 3 most popular vehicle. But you will have to kind of do some calculations on that. Okay. Now, one of the things I'm looking at right now, the calculation that you might have some trouble with, or I shouldn't say trouble, it might be a little bit more challenging. Now, you notice we want acceleration calculation is meters per second. And you look at all our calculations before, they're always in meters per second. Unfortunately, or meters per second squared. Unfortunately, for cars, we don't do that. Okay. For cars we use kilometers per hour. Okay. And if you're American, you use miles per hour, and I don't do that calculation. Okay. I don't do miles. So let me help you in terms of converting the kilometers per hour into meters per second. Hopefully that will make life easier for you. So let's see. Okay. So kilometers per hour into meters per second. Okay. So how do you do this calculation? Now, keep in mind, 1 kilometer per hour. So let's just say 1 kilometer per hour. Okay. This is actually, I'm going to show the proper way of doing unit conversion. I'm pretty sure if you're higher, or if you're math students, or you're very strong in math, you might see something similar to that. I don't know. But hopefully you can understand this. So at 1 kilometer per hour, now, 1 kilometer. Now keep in mind, what I'm doing, it's based on the math concept. Whatever number times 1 is still that same number, right? So let's say if it is 1 kilometer per hour. Now, what I want to do is I want to convert this, eventually becomes meters per second. So meters on top, seconds on the bottom, right? So in this case, to do that, I want to get rid of this kilometer business on the top. So now let me ask you this. So if I want to get rid of this kilometer, business on top and put meters on top. So I'll have kilometers here. So a times, basically times 1, right? So 1 kilometer. Now 1 kilometer is how many meters? Hopefully you would say 1,000. Okay, 1,000 meters. So if you think about it, 1,000 meters equals 1 kilometer. This is technically 1. It's 1. But because I've done this, and if you remember your fraction multiplication, you can say, that, kilometer, it cancels out. Okay. Now, so I can I can cancel out the kilometers. I can start having the meters up there now. Okay. Now, same thing. I want to get rid of this hour business on the bottom. I want to have seconds instead. So what do I need to do? Now, hour and seconds, it's not the funnest thing simply because time is not metric. So, and we have it's like you're jumping 2 different units, right? But so let's cancel this hour first. So if you have hour on here, you want 1 hour here. Okay, 1 hour. Now, 1 hour is how many minutes? 60. Okay, so 60 minutes, right? Okay, so I cancel this out. So if you look at this, now this again, 1 over 60, 1 hour is the same thing as 60 minutes. So this is equal to 1, right? So right now I have minutes and I have meters on top, which is exactly what I want. I have minutes on the bottom. That's not exactly what I want, but it's closer now. We'll do one more step. So in this case, I want to get rid of the minutes. Now I'll do this again. 1 minute is how many seconds? 1 minute is how many seconds? So in this case, 1 minute is 60 seconds. Hopefully you said that. So I get rid of this minute here, and the minute here cancels out. So now I have meters per second now, right? Meters per second. So now I've done a lot of fraction cancellation and stuff like that. What does that mean? Well, what it means is to have, so basically 1 kilometer per hour would means I'll have 1,000 divided by meters divided by 60 times 60 seconds. So if you put 60 times 60, hopefully you'll remember that you have 2 zeros, 36. So it'll be 1,000 divided by 3600 meters per second. Now I can, of course, cancel that out and probably and divide 1,000. Let's just keep it simple. 1,000 divided by 3600. That will give me 0.2777 repeated. So what this means, so what this means here is 1 kilometer per hour is 0.2777 repeated meters per second. So if you have a car that is 100 kilometers per hour, you want to convert that into meters per second, what you need to do is really just times whatever speed you have in kilometers per hour by 0.277 repeated. That will give you the speed in meter per second. So example, a car that is going 100 kilometers per hour, which is our legal driving speed. I want to find out what it is in meters per second. That you just need to do 100 times 0.277 repeated. And then in this case, if it is times 100, you know that it's just really moving this 2 decimal place that way. So it's 1, 2, or you can plug in a calculator if you want. 27.7 repeated meters per second. So that's how fast a car is, how fast a car is if it going, from kilometers per hour to meters per second. This is the speed. And to further confirm that, okay, we can always ask Google. But you should really know how to do this calculation yourself. Okay, so 100 kilometers per hour. Oh, look at that. Google's so smart. So in this case, really, it's 27 point. And there's a formula. Divide the speed by 3.6. So in this case, that's how you, so you can either multiply this by 0.277, or as Google suggests, which is a different way to do it, is divide whatever you have by 3.6. Okay, then you don't need to deal with the repeating business. Okay, so hopefully this calculation here will help you figure out, calculate out the acceleration, and that's your homework. Okay. If you have any questions, please make sure you please make sure you type in the questions, or anything you want me to clarify. Make sure you type it in at the end, so that I can actually look through all the stuff and give you a response video. Okay, it's much more clear that way. Have a good day. Bye.